With the first flight of the Ingenuity helicopter on Mars scheduled for April 12, 2020, let's try to wrap our heads around how a helicopter could possibly fly on Mars. To start, let's understand lift. An airplane wing, or any other type of airfoil, produces lift by having air pass through it. The more air a wing encounters at a time, the more lift it will produce, or the faster the air moves through the wing, the more lift is generated. The equation that describes the lift a wing produces is the coefficient of lift, which just depends on the angle of attack and the shape of the wing, times 1/2 of the density of the air, which we call rho, times the velocity that the air is moving through the wing squared, times the area of the wing. Now, we don't just blow air over the wings with a fan to make the planes fly. The plane itself and the wing itself need to actually move through the air at high speed to make this velocity high. Now, here's where you can see the main difference between a plane and a helicopter. A helicopter's blades are the same thing as a plane's wing. But a helicopter has them mounted up here and they move independently from the helicopter, while a plane has them firmly attached to it, so the plane actually needs to move with the wing in order to produce lift. This means that the plane itself needs to move quickly and not just the wings. That's why a plane needs a runway to take off and can't just stay steady and hover like a helicopter, because the whole plane needs to move fast enough in order for the wings to produce lift, while a helicopter just has to have its wings move fast enough. That's why the Ingenuity helicopter on the Curiosity rover is a helicopter and not a plane, because there isn't any runway on Mars, and the plane could get damaged while taking off. But there were some challenges when designing it as a helicopter. One was that Mars's atmosphere is 100 times less dense than Earth's. And that's a problem for creating lift, because from this lift equation we can see that a higher density of the air will create more lift. So if the density is really low, we have to compensate that by either making the velocity higher or the area or both. If we wanted to make just the area higher, that wouldn't be quite feasible, because the blades on the helicopter would need to be huge and they wouldn't be able to fit inside the rover. So we'd have to increase the velocity. And since the density is 100 times less than on Earth and the velocity is squared, we need to multiply the velocity tenfold in order to compensate this out. That's why Ingenuity's rotor blades will be moving at 2,400 RPM, so that they will be encountering a lot of air very quickly, so they can produce the most lift possible. Now, the issue was, in order for it to reach that high of an RPM, the electric motor consumed a lot of power, and for it to still be small enough to fit inside the Perseverance rover, the batteries would have to be small, and therefore it would not have enough power to sustain a long flight, and that's why it will be taking only small trips. So the first flight, scheduled for April 12th, will go on like this. It will first rise up to 3 meters and then turn towards the rover, take a picture of it, and then come back down.